Hi, thank you for attending our talk. This is Room for Escape, Scribbling Outside the Lines of Template Security. My name is Alvaro Muñoz, also known as Point Tester in the social media. I'm a staff security researcher with the GitHub Security Lab team, and my colleague Oleksandr Mirosh, or Oleg Mirosh in Twitter and social media, which is a security researcher with the MicroFocus Fortify team. So today we will be talking about content management systems, or CMSs, and in particular the template systems that they use to render dynamic content. So a CMS is an application that is used to manage different web content, and it basically allows multiple users and contributors to create, edit, and publish content on these systems. So what is important to us is that this content is normally rendered based on a system of some documents called templates, and these templates are normally mixing both static and dynamic content. So for the evaluation of that, of those dynamic parts in the templates, these systems are normally using some subset of some programming language capabilities, which are powerful and normally are able to get remote code execution. So these systems are normally sandboxed in order to prevent that. So our research will focus basically on .NET and Java-based content management systems, because those are normally the languages that are more used by enterprises. And our assumption is that the attacker can control the contents of a template, right? So it doesn't matter if it gets control of those templates through a server-side template injection, or maybe they can control it because they have permission to do that because they are author of some different systems, or they have, for example, a user in a SharePoint or something like that. So our goal here is to basically be able to escape those sandboxes and run arbitrary system commands on the underlying servers. So we will divide our talk into two different big blocks. The first one will be around .NET, although we will basically focus on SharePoint. And we will show 5 different ways we were able to break the SharePoint sandbox. And then we will move into the Java part, where we will be reviewing 10 different content management systems and up to 4 different template engines, including the most popular ones, FreeMarket and Velocity. So with that, we will wrap up with some takeaways, and then we will open the floor for some Q&A.
Thank you, Alvaro. In this part of our presentation, we will see examples of different types of security problems in SharePoint server. But before that, we need to explain some basics of SharePoint security. SharePoint has 2 types of ASPX pages. The first type is application pages. Actually, each of these pages is part of SharePoint server and implements some application logic. They are stored in specific folders in the file system, and of course users are not able to change them. They are regular ASPX pages and are processed by the server without any restrictions. In opposite to them, there are site pages. They are stored in databases and they can be customized even by users. SharePoint parses them in special mode, also known as safe mode. Actually, they are more like some sort of templates for dynamic content. On this slide, we can see a diagram how server works with these pages. Virtual provider can fetch content from file system or database. Based on the virtual path of the current page, SP page parser filter will decide either it is site page and safe mode should be applied, or it is application page and it will be processed without any restriction. So page filter is a critical element from security point of view in SharePoint. Let's have a look at sample ASPX page. For our talk, we are interested only in server-side components, like directives. There are special instructions on how server should process this page. Often they have some numbers of attributes with values. We can include server-side code either in special blocks or as embedded server-side code. Server-side controls should have the runat server attribute. Server-side comments block will be ignored on the server. And the last element, server-side include directives, allow us to include raw content of arbitrary files. Now we can better understand what safe mode means. Site page will not be compiled, so we cannot use server-side code here. We are not able to include files from file system. We can only use allowed controls. This list is defined in Safe Control section of web config file. Page filter also applies allow list for directives and even for attributes of most of them. There are many other restrictions. For example, event binding is blocked as well. This set of restrictions looks quite impressive, but let's look possible type of attacks what we can perform. As we know, safe mode is enforced by page filter. So our first question was, is there any place where SharePoint does not use it? And answer yes, there are such places. Page filter will not be applied for the content argument of the parse control method, if it's called only with one argument, or if the second one that actually is named ignore parse filter is true. In addition, page filter will be used at rendering time, but ignored in design time. But even if page filter is not applied, SharePoint uses another way to verify the input. It is verify control on safe list method from editing page parse type that aim to do the same task as the original page filter. So, what we can do? Let's imagine for 1 second that we are able to bypass either this method or page filter. By the way, each such bypass is separate vulnerability. We will present them in a few minutes. So, how could we get remote code execution after escaping safe mode? Since parse control method never calls compilation, we are not able to use server-side code or perform other attacks that require such compilation. But if we escape safe mode, we can use unsafe controls or directives. So let's review a few of them. One of the most interesting unsafe controls is object data source. It allows us to invoke public method from arbitrary public type. We can see an example of payload that uses the start method from process type to pop-up calculator. So actually it is arbitrary code execution by definition. Game over. But let's review a couple other unsafe controls. XML data source and XML controls allow us to get the content of arbitrary XML files. The similar results we can get by server-side include directives that return us a content of any text file. Let's see on the next slide how we can escalate from arbitrary file read to arbitrary code execution. If we can access the web config file, we will be able to get value of validation key from machine key section. By the way, this value may be present in other places, such as internal SharePoint properties. You can find this example in our white paper. With validation key, we can generate a valid view state that will be executed arbitrary commands on the target server. You can use tools such as usoserial.net to generate this payload. Now, when we know what safe mode is and how we can compromise SharePoint server if it's bypassed, we can move to our next part. Here we will present 5 different types of security problems in content management system. We will show examples of each type in SharePoint. We would like to stress here that our target is SharePoint server with default configuration. All vulnerability allowed us to execute arbitrary code on the target. All attacks were performed by regular users, and no admin rights were needed. Let's start. The first type of security problems is access to resources with sensitive information. It can be configuration or business information in various files, logs, databases, or even process memory. Of course, a proper sandbox should prevent this problem, but it's not always the case. We already mentioned that page filter blocks server-side include directives, and verify control on safe list method should do as well. And actually it does, but if it's called with false in block server-side includes argument, it will not block them. We found such usage of this method. It was used for design mode. The next building block for our attack, how can we provide our markup to this mode? We can send it in the web part XML parameter of the render web part for edit method of the web part page services. So we can try to include web config there. Here we can see the full payload that will be sent in mentioned parameter, an address of relevant web service. server returned us the entire web config with validation key. We used it for view state-based deserialization attack, which led us to executing arbitrary OS command on the server. Time for our next type of security problem. Allow dangerous element that can be used for attacks. We have found an example in SharePoint safe control list, or should we call it not so safe control list in this case? It is contact link suggestion MicroView Control. We can see snippet with interesting code from its implementation, where request parameter is passed into dataset.read XML method. If we can control input for this method, we can get our data deserialized by XML serialized and be able to control a destination type. We already showed in one of our previous research that in this case we can get arbitrary code execution. Unfortunately, this payload is too big for slides, but you can find it in our white paper. The last piece of our puzzle is site page with this dangerous control. We can see it on our slide. For attack, we need to place the payload into text box and click on the submit button, and desired command will be executed on the SharePoint server. For us, the next type of security problems look quite interesting, so we will try to explain it with more details. Dynamic content usually means that we will have at least read access to some properties or attributes of some objects. For some systems like SharePoint, we can even have write access. Sandbox should filter out the access to dangerous properties or attributes. Let's review basic types of such filtering. The first case is when only one level of properties or attributes is allowed. We can see examples on the slide: name property of user object or selected value from menu. We can imagine the object and its property like branch with only leaves. If an allow list is applied, it is relatively easy to review all elements, and after such review we can make sure that there is no dangerous element. What if a block list is used instead? We still need to verify all available objects, and it can be a bit difficult. So in general, we do not consider block list a safe approach because of potential gaps on them. We will see in Java part of our presentation a couple examples of such bypasses. The most interesting case for us is when access to nested property or attributes is allowed. For example, request.authUser.name or menu.selectedItem.text. Because of branch leaves analogy, many developers may imagine this case as branch with branches and leaves, and they can apply filter only for the first level objects. But it's not tree, it is network, and we may jump from one branch to another or even to the trunk. For example, on the slide we can see how to access application instance from menu control. Let's move to our example in SharePoint. It has wiki content web part control. It is allowed and will pass our markup into the parse control method. Please note, it is called with false value in ignore parse filter argument, so page filter will not be ignored. The following snippet show that in this case the virtual path will be created from up relative virtual path property. And if you remember, page filter will apply restriction based on this virtual path. So if we are able to change it, we can fool the page filter not to apply restriction at all to our markup. Let's try to craft such payload. First snippet fails, because when ASPX parsers try to assign a new value to our up relative virtual path, the page property of our control is not defined yet. So we need to delay this assignment a little bit. This can be done using data binding. So by time the property is bound, the page property will be already defined. Here is our final payload. We can notice that our new path points to settings page, its application page. It is assigned to tooltip property and later will be transferred to up relative virtual path. So the page filter will think that This is system page and will allow any unsafe markup. For example, we can use our object data source control to pop up calculator. Let's see how this attack looks on real SharePoint server. Here is our site page with payload. Here is path to the system page. It will be transferred to upper relative virtual path. Here is our unsafe markup with object data source, start method, process type, and calculator file name. Let's save it here. For our attack, we need to upload this to SharePoint server. Our target is SharePoint with default configuration. In this configuration, regular users usually have access to their own personal site, so we can use it. We are attacker, it's regular user, no admin rights. So here is a personal site. Let's upload our page. To trigger our attack, we just need to click on it. But before that, let's pay attention on the other window in the screen. It is Task Manager, so we will on this SharePoint. So we will see if a calculator starts. Actually, it started. Attack was successful. By the way, we were able to exploit read access to nested properties in SharePoint, but unfortunately we do not have time to present this vulnerability today. You can find all details in our white paper. Now let's move to the next type of security problems. It is connected with our previous work on unsafe decentralization. Such kind of problem is relevant when text or binary data is converted to an object and the type or class of this object is under attacker control. Also, it is not properly limited. Actually, it doesn't really matter what mechanism is used. Classical deserializer, JSON unmarshallless, type converters, or even some custom approaches. All of them are potentially dangerous. Also, for successful exploitation, attackers may need to find proper gadget on the target system. We have found an example of such problem in SharePoint server and were able to perform arbitrary code execution attack using it. Microsoft assigned a CV number to this vulnerability, but because this problem affects a few other products, Microsoft was not able to release fixes for all of them in time. So we are going to publish all details of this vulnerability a bit later when all fixes are released. The last type of security problems in this part is the classical time of check to time of use problems. They occur when the server validates some input, but it can be later changed. Before that, server is used. We found such problem in web part editing surface page. User input is validated by the already known for us verify control on safe list method. But later, the server may modify the input and remove some substring from it. Let's consider the next content. For verify control on safe list, it is just one server-side comment block, so it will pass validation. But SharePoint removes the yellow substring and parse control will see two comments and some markup. Note, parse control has only one argument, so page filter will be ignored. Time for our payload. We can notice here our unsafe object data source control and calculator. Of course, in all our examples, we could change this command to a more interesting one and compromise SharePoint server, but it would be another story. Now let's switch back to Alvaro and he will present the Java part of our research.
So thank you, Oleksandr. Now we will be focusing on the Java part. For that, we analyzed 4 different sandbox Java template engines, including the most popular ones, which are FreeMarker, Velocity, and also GenJava and Pebble. And in order to test our bypasses, we will be testing them on different CMS-like systems such as LiveRay, Alfresco, Confluence, or HubSpot, just to mention a few. So a brief introduction into what a content or a template engine is, basically. We have a template which is mixing both static and dynamic content, and then the template engine is resolving and expanding this dynamic content by using some objects that are available in something that is known as the template context. So in this example, the user.name expression will be resolved by accessing the user object and then invoking the getName property, the getName getter in this object. Because this invocation is dangerous and can lead to bypasses or arbitrary code execution, then these template engines are normally sandboxed in order to prevent further access of methods through reflection that should not be allowed. So apart from those objects like user that are directly used in the template, these frameworks and these content management systems normally expose a number of other objects to the template context. This is known as the template API, and it includes things like the servlet request and response, the servlet context, just to mention a few. So the first kind of bypass that we will be using is trying to find objects in this context which can be used to get remote code execution, right? So these are generic in the sense that no matter if it's we are using GenJava or FreeMarker, those should be working regardless of the engine. So first of all, we need to see and analyze what is in the context, right? So for that, if we get access to the Java runtime, we can instrument it or debug it, then dump the context and analyze those objects. If not, we have to read the documentation, maybe brute force or guess some common names like request or rec or response resp, for example. And then in some cases like FreeMarker, we are able to actually list all the objects in the context through some special variables. Apart from those objects that are directly exposed, we have some indirectly exposed objects. Like for example, if the request is exposed, all of the request attributes are exposed as well. So same thing with the session and the servlet context. And we will be able to find very interesting objects in this set of attributes. So let's see an example of how many objects we are able to find in a regular content management system, like for example, LiveArray. That's what we call object dumpster diving, and you will see why in a few minutes. So this is the template that we will be using. First of all, we will be listing all the context objects by using the .data model variable. Then we will be listing all the attributes in the request, and then the attributes in the session, and then the attributes in the servlet context. And because the servlet context gives us access to the Spring application context, we will also be listing all of the Spring beans that are available to us. So if we render this template, we will see all of the context objects. Those are normally exposed by the framework or CMS, and those are kind of safe sometimes. But apart from that, we have access to a bunch of request attributes, a bunch of session attributes, and a bunch of servlet context attributes, including things like the instance manager that we will be using to get remote code execution. We also have access to the Spring Web Application context, as we mentioned, which will give us access to all of the Spring beans registered in this context, which are in the order of hundreds. So we get a total of almost 900 objects available to us. And those are objects that expose other objects. So we normally get access to thousands of objects. So this is why we call it object dumpster diving, right? Because this is how we felt like looking for few interesting objects in hundreds and thousands of objects that in most cases should not even be exposed to the template in the first case. So we will be reviewing the top 3 objects that lead to remote code execution that we were able to find. And the number 1 will be the class loader, which was available in 10 out of the 10 content management systems that we analyzed. This is normally available through the class object, but since that one is normally blocked, you can still get access to it through either the protection domain or servlet context, which are normally not non-blocked. Once that we get access to a class loader, we can obviously load arbitrary classes or class path resources from that class loader, but we can also read any arbitrary file from the file system by accessing a URL object and then pointing the underlying URI to our arbitrary file and then opening a connection and reading the bytes from that connection. So because these content management systems are normally deployed on top of an application server or servlet containers, then those class loaders that we are going to get access to are normally instances of web application class loaders, which expose a number of features and capabilities on top of the regular class loader ones. So we were able to abuse those additional methods to get remote code execution in 9 out of the 10 CMS-like systems that we analyzed. And we don't have time, unfortunately, to cover them today because they are sometimes complex and we don't have time in this 40 minutes presentation, but they range from being able to upload a web shell, to instantiate arbitrary objects, to perform JNDI injection attacks, or to initialize attacker control classes, leading to the execution of the static initializer of that class. So the number 2 object that leads to remote code execution and that we found in 9 out of the 10 CMS-like systems that we analyzed is the instance manager. So an instance manager is an object that is capable of instantiating arbitrary types. You normally find it either as part of the servlet context attributes or through one of these web application class loaders that we mentioned before. Once that we get access to the instance manager, sometimes also called object factory, you can instantiate arbitrary types. In this case, we are instantiating the script engine manager in order to evaluate arbitrary JavaScript and Java code. But once that you can instantiate arbitrary types, you can get remote code execution through a number of different vectors. The number 3 object that we found in 4 out of the 10 systems is the Spring application context. Actually, the only 4 systems that were using a Spring framework underneath to manage the dependency injection. So we were able to access the Spring application context through the servlet context attributes, but also a Spring MVC, if it's been used, will inject a variable called a Spring macro request context into the template context. And you can use that one to get access to the web application context. So from there, you can get access to the class loader, to the environment, including things like the environment variables, but also the Spring properties, which will include things like encryption keys and other interesting stuff. But probably most interesting is the access to the Spring beans, right? As we saw in LiveRay, we get access to hundreds and hundreds of objects, which are normally meant to control the application logic, right? Things like creating new users, deleting users, creating new transactions, and things like that. And because these are normally behind the layer of authorization, they will give you access to those operations without any further authentication or authorization checks. You can also do other interesting stuff like disabling the template engine sandbox altogether, and also instantiate arbitrary objects through things like JSON and Marsaler or an XML deserializer. So those were like the top 3 ones. We found other objects leading to remote code execution, plenty of them, but we don't have time to cover them today. Again, this will be explained and covered in the white paper that we will be releasing. So those were generic in the sense that they were dependent on finding objects in the context, no matter if that was the context of the GenJava engine or the FreeMarker one. Now we will be reviewing some of the specific bypasses that we found for these 4 different template engines. So we will start with FreeMarker. It's probably the most popular one, also the one that got more attention from the security community, starting by James Kettle, who presented back in 2015 this presentation about server-side template injection, actually introducing the whole category type. And he found a way of bypassing the sandbox by using an add-on that was part of the default configuration at that time. So Tony Torralba found a different bypass, being able to instantiate arbitrary objects, but this bypass is not universal in the sense that it depends on one of these add-ons that is not part of the default configuration, and also being able to access some special fields in some objects in third-party libraries, which are not part of the free marker distribution. Last but not least, Ryan Hanson, at the same time that we were performing this research, published a bypass that works only in Tomcat and that leads to remote code execution by uploading a web shell. So those were like the ones that we were aware of. And then we will be reviewing the sandbox in FreeMarker. So this sandbox is based on blocking individual methods. Like for example, the Java-Lang class getClassLoader method is blocked. You cannot invoke it. But as we mentioned before, we have different ways of getting an instance of a class loader, like for example, using the servlet context. Then all the class loader methods are allowed. They are not blocked by this block list. So if you find an instance of a web application class loader that is already jackpot, you can get remote code execution. Otherwise, you can still get access get remote code execution by accessing public static fields, which is also allowed by the block list. So in order to do that, we found interesting public static fields within the FreeMarker library. So we use CodeQL for that. If you are not familiar with CodeQL, it's a language that allows you to query source code as you query a database, for example, using SQL. And we don't have time to explain the query here, but the idea, what we are asking for is, okay, find me all the public static fields which contain, or of a given type, which contains a method that allows me to instantiate arbitrary types. So running this query on FreeMarker code, we found 4 different results. All of them are fields from different interfaces or classes, but what they have in common is that all of them extend from the beans wrapper class. And this class contains a new instance method, which will allow us to instantiate arbitrary types. So with that, the universal bypass is basically based on getting an instance of the class loader, either through the protection domain or through the servlet context, and then loading the object wrapper interface, and from there grabbing the default wrapper field. Because this field contains the new instance method, we can instantiate arbitrary types. In this case, to keep the bypass self-contained in FreeMarker libraries, we are using the execute class, which will allow us to invoke arbitrary system commands. So this was fixed in FreeMarker 230 back in March, and it's still vulnerable if the legacy access policy is configured, but that's not the default. So as we mentioned before, if you get access to the Spring beans, you can also disable the sandbox, in this case by accessing the FreeMarker configuration and then getting the default configuration that is non-sandboxed and getting the class resolver from there and setting that class resolver as the class resolver for the current and sandboxed configuration. So effectively disabling the sandbox altogether and re-enabling the old payload by James Kettle from 5 years ago. So now switching to Velocity. Velocity Sandbox is also known as Secure URSpector and is pretty effective in the way that it's not based on individual methods. It's blocking whole namespaces and also classes. So for example, the Java-Lang reflect namespace is blocked, so you cannot use Java reflection API. You cannot use any method on class or on class loader classes, for example. But we found a flaw in the implementation of this sandbox because when they are checking this block list, they are not checking the whole hierarchy of the classes for the method being invoked. Like for example, when we invoke the load class from the class loader, we are not checking the whole instance, the whole hierarchy of this object, right? We are just checking the current type, which in this case, because it was deployed on top of Tomcat, it's an instance of parallel web app class loader. But what it's important here is it won't be an instance of the Java-Lang class loader. That is the only one that is blocked by the block list. So with that, we are able to basically bypass this limitation and execute arbitrary methods from class loaders and get remote code execution. So this was fixed in version 2.3. Now moving to the GinJava sandbox, this is based in a very short method-based block list, which is only blocking 9 different methods. But it contains a piece of code here at the right, which will basically improve the protection by preventing any method from returning an instance of Java lang class. So if we cannot get an instance of Java lang class, we cannot instantiate arbitrary types. That's normally the case. However, there was a flaw. Again, in this case, they are not blocking invocation of methods which return arrays of classes or map of classes. So that was the first part of the bypass. The second part is that they are exposing this secret or hidden keyword called interpreter in lit speech, which will give you access to a bunch of objects, including all the objects in the context, but also the exposed functions, filters, and some other objects. So putting these two parts together, we were able to get the context from the interpreter and then getting all the functions exposed to the context and then getting the underlying method for one of these functions. And now we are able to get an instance of the Java lang reflect method type. From there, we can get can use the get parameter types, which will return an array of classes, and then access an individual element of this array in order to get finally an instance of a Java lang class. From there, you can get an instance of the class loader and launch any class loader based attack. So this was fixed in version 2.5.4, and that got this CVE. So now we will move to Pebble, which unfortunately we found a couple of bypasses. We reported them to the maintainers, but they were not fixed on time. So we decided not to release the bypasses so far. So with that, we will switch back to Oleksandr to wrap up with some takeaways.
Thank you, Alvaro. First of all, let's summarize our results of this research. 30 new vulnerabilities were found and reported to the vendors. 20 different products are affected. You can see their names on this slide. Based on these results, we are able to make the next conclusion. Content management system should be on the radar of red teams. Template for dynamic content that can be managed by user is the main target in such systems. There are specific areas with higher risk from security point of view. It is a good idea to perform security review and testing for such places. Always try to reduce attack surface as much as you can, and stay safe. Thank you very much for your attention, and we hope we still have a couple minutes for the answers on your questions. Hello everybody. If you have a question, we will be here in chat window for the next 20 minutes and we'll try to answer them. Slides and white paper should be published today evening on Black Hat server. So check it out later in the evening.
Also, we will be hosting a Q&A session of 30 minutes tomorrow at 10:30 a.m. Pacific time. At the DEFCON version of this chat, of this talk, sorry. So if you have any questions that we were not able to answer today, you are very welcome to join our Q&A session tomorrow, and we will be answering all the questions. So I think we have a question, but it's already answered. So the white paper will be available in the Black Hat server in the same page where the talk is announced. Where the briefing is announced, both the slides PDF and the white paper PDFs will be published. And I think that will be later today or maybe tomorrow. So with that, I think there are no other questions, so we can thank you all for attending our talk. We really hope you liked it. And again, if you have any questions, we will be hosting this Q&A session tomorrow. Thank you.
Thank you.